So hi guys, we have learned that oxygen gas is very important to humans and animals as it aids important processes like combustion and respiration. In this lesson, we will see how to prepare oxygen gas in the laboratory. To start with, oxygen can be best prepared in the laboratory by the decomposition of two compounds. They are potassium trioxychlorate 5 and hydrogen peroxide. We will look at these decomposition processes in depth, starting with the decomposition of potassium trioxychlorate 5. The apparatus and reagents needed for this experiment include a boiling tube, retort stand, delivery tube, rubber stopper, Bunsen burner, gas jar, a trough of water, manganese 4 oxide, and potassium trioxychlorate 5. The potassium trioxychlorate 5 is put in the boiling tube alongside manganese 4 oxide. Note that in this reaction, manganese 4 oxide plays the role of a catalyst. That is, it does not affect the products formed, it just makes the reaction faster. At this point, a setup similar to that displayed in this image is made, and the mixture of both solids is heated using the Bunsen burner. As soon as the temperature of the reaction mixture surpasses the melting point of the trioxychlorate 5 salt, the salt decomposes and erupts oxygen gas violently, which travels into the delivery tube. The oxygen gas is delivered into the trough containing water, and being insoluble in water, it displaces water and is collected in the gas jar. The equation that represents this reaction is given by the decomposition of potassium trioxychlorate 5 to yield potassium chloride and oxygen gas. The second method of preparing oxygen is the decomposition of hydrogen peroxide. It follows the same procedure as the decomposition of potassium trioxychlorate 5. The only difference is that hydrogen peroxide will readily decompose in the presence of manganese 4 oxide catalyst, even without heating. The apparatus and reagents are set up in this manner, with hydrogen peroxide being added in drops to a conical flask containing manganese 4 oxide catalyst. On reaction with the catalyst, hydrogen peroxide decomposes to give off oxygen gas, which travels through the delivery tube and is collected over water in the gas jar. The equation that represents this reaction is given by the decomposition of hydrogen peroxide to yield water and oxygen gas. Note that the gas obtained in both cases contains water as an impurity, so it must be dried. The gas is dried by passing the wet gas through calcium chloride and then collecting it over mercury, since liquid mercury does not dissolve oxygen. The preparation of oxygen gas by decomposing hydrogen peroxide is preferred to the decomposition of potassium trioxychlorate 5 because the oxygen produced by the decomposition of potassium trioxychlorate 5 can cause instant burns of any rubber material present in the setup. With what we have learned in this lesson, I am sure that we all now know that oxygen may be prepared in the laboratory by the decomposition of potassium trioxychlorate 5 and hydrogen peroxide.